What's up, scholars? Today we're going to talk about simplifying complex fractions. What's a complex fraction, you ask? Well, it's a fraction that contains one or more fractions within itself. It's like fractionception. Fraction within a fraction. So we see this guy here. There's a fraction in the denominator of a fraction. This one here has a fraction in the numerator of a fraction. And this one here, oh my lord, it's a fraction in the numerator and a fraction in the denominator. Whoa. All right, let's learn how to simplify these complex fractions. So we got a fraction on the top, x plus 3 divided by x. All that divided by x plus 4 divided by 7x. So we're going to make this into a multiplication problem, which will be much easier to deal with. So here's our numerator. Here's our denominator. We're going to take our numerator and multiply it by the reciprocal of the denominator. So we're doing a keep, change, flip situation. So we'll have x plus 3 over x times the reciprocal of the bottom, 7x over x plus 4. Much better, much nicer. We know how to deal with multiplying fractions. We just multiply straight across. So let's do that. Shall we? I think we shall. 7x times x plus 3, or quantity x plus 3 times 7x on the top, and x times x plus 4 on the bottom. Now let's distribute on the top. That's 7x to the x and the 3. 7x times x is 7x squared. 7x times 3 is 21x, all divided by, distribute that here, x times x, x squared, x times 4, 4x. Okay, so we've done our multiplying. I feel like we can simplify some more, because I'm pretty sure we can take out GCFs in the top and the bottom. And something's going to cancel. So let's do that. What's the GCF of 7x squared plus 21x? You are correct. It is 7x. Take out a 7x and we get x plus 3 on the top. Ha! On the bottom, what are we going to get? GCF is x. X plus 4. I went a little hard there, didn't I? Because we're getting back exactly what we got before. So let's see what can cancel. We should have done that earlier. I just wasn't paying attention. I was just following right through. You know, as one does sometimes. Regardless, we're still going to get the correct answer. And we practiced our distribution and factoring again. So it's all gravy. What can we cancel out? It's the same on the top and the bottom. The x's. So now we have 7 times x plus 3 over x plus 4. You can leave your answer like that, or you can multiply it out and get 7x plus 21 over x plus 4. Either one of those answers are cool. So let's recap. We had a fraction divided by a fraction. We changed that into a fraction multiplied by the reciprocal of said fraction. Then I went a little extra and did some multiplying when I should have just canceled out the x's right from that beginning. And then get our final answer or distribute out and get that as an answer. Again, either of these answers are appropriate. All right, let's look at example 1. Cool. Again, we have a fraction divided by a fraction. That sounds terrible. Let's change that into a fraction multiplied by a fraction. x squared plus 3x divided by 4. Ooh, sorry about my phone making some noise. Multiplied by the reciprocal. Okay, hush. You just need to hush now, is what you need to do. Telephone, making noise during my video. Rude. Got a fraction divided by a fraction, so let's make it a fraction multiplied by the reciprocal of that fraction. So now x squared is on the top. X plus 3. I think I see something that I could cancel if I took an x out of this numerator. Like if I factored out an x here, this would become x times x plus 3, which would cancel with that guy, so let's do that. X times x plus 3 over 4 times x squared over x plus 3 by. Look at us, seeing our stuff early, not doing extra work this time. That's good. So now all we're multiplying is x times x squared, which is who? X cubed divided by 4. Que bueno. Très bien. Cool. All right, let's go on to the next one. Not too shabby. Simplify this expression. Oh my, oh my. We've got two fractions being added in the numerator and a fraction in the denominator. So let's first make this into a fraction times a fraction. So that's our numerator, times the reciprocal of our denominator, so times x minus 3 over x minus 1. Cool. But this actually isn't a fraction yet. Right? These are two fractions being added together. So we're going to use our knowledge of adding fractions so that we can get these guys to add together. What's our least common denominator for these two fractions? Well, they both have an x. That's cool. This one's got a 2, this one's got a 3, which to me says I must multiply the left fraction by 3 on the top and 3 on the bottom. And we shall multiply this fraction by 2 on the top and 2 on the bottom. Then they all have the 2 and the x and the 3. The 2 and the x and the 3. Okay. So this fraction, or this addition of fractions, becomes 1 times 3, which is 3 over 6x plus 4 over 6x. We didn't do anything with this, so that's just coming along for the ride. Cool. These have common denominators. The point of that was what? So we could add them together. Beautiful. So 3 plus 4 is now 7 over 6x times x minus 3 over x minus 1. I'm not seeing anything that's going to cancel here. So let's go ahead and do our multiplying. 7 times x minus 3 over 6x times x minus 1. You can leave your answer like that. Or if you're feeling saucy, do your distributing and get 7x minus 21 over 6x squared minus 6x. Either one is good. They're both pretty great. Loving it and loving it. Alright, friends, last one. Again, let's change this into a multiplication so we don't have to be dividing fractions all the time. Sounds awful. Multiplication is much better, much easier on the mind. So let's take our numerator, x over x plus 1, multiply by the, what? The reciprocal of the bottom. It's like x over 1. What? I don't even know what that is, man. It's two fractions being added together. I say let's make this into a fraction first, and then we'll multiply by its reciprocal. So we have x over 1 plus x over 3. So again, we're taking our bottom fraction, trying to make it into a fraction so that we can multiply by its reciprocal to finally simplify our expression. Okay, this denominator is 1, this denominator is a 3, so I'm going to go ahead and say the least common denominator is 3. So we're going to multiply the left fraction by 3 and get, you guys like my different colors thing happening? I think it's pretty cool. 3x over 3 plus x over 3. Again, what was the point of that? Now we can put them together as one fraction. 3x plus x over 3. What's 3x plus x? It's definitely 4x. 100% 4x over 3. Okay, cool. So that's what this denominator simplifies to, is 4x over 3. We were originally dividing by 4x over 3. So we're going to multiply by its reciprocal, meaning multiply by 3 over 4x. Cool. Do you see anything that's going to cancel out? I see it too. I see it. See some x's. Bye, x's. See you later, alligators. So now all we have on the top is what? 3. On the bottom we have 4 times x plus 1. That could be your answer. Or you could say 3 over 4x plus 4. So good. All right, what's the moral of the story? When you have a fraction divided by a fraction, make it a fraction times the reciprocal of said fraction. If you've got a thing that's like not even a fraction yet together, you've got to make it a fraction. So you can do your fractiony fractions. Fractions stuff. Okay. All right, love you, scholars. Work hard. Keep on hustling. Get it.